Hi, this is Todd Geis, and welcome to this little tip video on how to speed up your slow reports in FileMaker. And the way that we're going to do that is getting rid of unstored calculations. As we'll see in the demo, unstored calculations can have a dramatic impact on your FileMaker reports, or really any layout that references a large number of unstored calculations can get slow. And this is amplified when you have a database that you're accessing over the internet or through FileMaker 13's web direct. One of the things you can do is something called denormalizing. This is a general term, but it basically means denormalizing the schema of your database so that you're storing data in more than one place. Now that, in theory, sounds like a bad idea, and in theory it is a bad idea, but in practice you really need to do it if your FileMaker database is going to be able to scale at all. If it's going to be used over the internet, you pretty much have to do that in some places. And really what that amounts to is moving as much of the data as you can into stored fields as opposed to unstored calculations. And if you do that, you get a lot of benefits. The problem with unstored calculations is that they are only calculated when needed. So whenever you display a layout that's referencing a large number of unstored calcs, all of those calculations have to be resolved before that layout can draw. So the more unstored calculations you have, the longer that layout is going to take to resolve. So in the demo, we're going to take a look at a report that is really, really slow, and then we'll take a look at how to speed it up. All right, so let me just go through what this demo is all about and talk about the logic, that the business rules that we're looking at, and look at the slow report. We'll start off with that. So this is just a very simple work order solution. We have a lot of data in the database. We have 20,000 work orders, and probably, I don't know, hundreds of thousands of lines or 100,000 work order lines in there. So this represents a database that's been in use for a while. It's maybe a few years, collected a lot of data, and the basic problem we're going to look at is a kind of simplified inventory report. So let me show you what that is. So here is our slow report, and you notice that I'm scrolling. You see it jumping around. I'm trying to scroll there. We get the spinning beach ball. Do you see that up there on the screen? We get that sometimes as I'm trying to scroll around this layout. It's just really slow. Now I should point out that this database is actually running right here on my computer. It's not on a FileMaker server. It's not being accessed over the network or the internet or web direct or anything like that. So these are sort of the optimal conditions under which you can run a database as far as getting the best performance. And you can see it's still very, very slow. I mean, it just really doesn't scroll, and we get these beach balls you can see up there on the screen every once in a while. And so it's pretty much unusable, and it would get worse. If you're on the internet, you would not be able to use this report. It just wouldn't resolve. Minutes of spinning beach balls, you'd have a real problem on your hands. So why? Why is this so slow? So the report is basically calculating two numbers. It's calculating the number of each of these inventory items on open work orders and on closed work orders. So this is a kind of a simple inventory report. It shows how many items we've sold. The closed would represent the sold items, and how many items we're actually working on right now that are on active work orders or open work orders. So you can see in this one here, this nickel slide bar with hand shower has 15 items, 15 quantity on open work orders, and 4,500 that have been on closed work orders. So the way that we're calculating that is let me jump back to the work order here. So what we've done is we have created calculations, and let me actually create a couple. Whoops, I want to do this, and we're going to look at unstored, and we're going to look at stored. I want to show these quantity open. I want to show these in context so that you can see what's happening here. So let's change the formatting. Those shouldn't be. Let's not have those be currency. Let's just have those be general numbers. There we go. So you can see that in this case here, this is the unstored. This is the unstored quantity open. So this is showing. Let me put a little gap in here so we can see that a little better. So this is showing the number of items that are on an open work order. And if we change that to closed, we're going to shift all those over to the closed version. Okay. So that's just some simple logic. Let's look at that here in the database. So work order items, and here is our unstored quantity, and we're basically just looking at the status of the work order. If the status of the work order is closed, then we put the quantity in. If it's not closed, we put nothing in, empty. And then we have the same thing for open. So if the work order status is open, then we put the quantity and nothing for if it's closed in that case. So what that gives us are two different numbers, one for stored work orders, one for open work orders and one for closed work orders. And then in our inventory report, let me change this back to open here real quick. In our inventory report, we are simply doing a sum across all of the work order items for each of those values. So if I look at those calculations here, so here's the total closed, and it is simply the sum of all the work order items that are closed. So the work order items that are on closed work orders, and we have here for the other one is sort of the other side of that. So the basic problem is that there are maybe hundreds or thousands of related work order items to each of these items. So FileMaker is having to go through 1,000 maybe or hundreds at least work order items and then summarizing an unstored calculation. And the reason that is unstored, if we switch back to work orders, is because work order items, this has to be unstored because we are looking from work order items to work orders, and since that's a related record and not a related table and a related record and not the local table, that calculation has to be unstored. So we are basically forcing FileMaker to do thousands and thousands and thousands of calculations before it can come up with those numbers, and that is why the report is so slow. So that's a look at why it's so slow. Let's look at how we can speed that up. Okay, so let's take a look at this a little closer here. So let's take a look at this particular item here. There's 8 on this work order item, on this work order here. So it's quantity 8. And if we look at the report over here, if we wait for it to resolve and then scroll up to the top and wait for that to resolve, we're going to see that there's that same item and there are 15 on it. So let's just make sure that it works in the way that we have it set up. So we'll change the work order from open to closed. And what we would expect is when we go back to the inventory report that number for that guy is lower. For the open quantity is now, I think it was 15, so now it should be 7. So let's wait for it to resolve. It's spinning beach balls. And there it is, and yeah, sure enough, it's 7. So our report is working, but it's slow. So let's see if we can speed it up. Let me shift that back to open, and we'll start there. All right, so first thing I'm going to do is I just want to change this out and go back to, I want to add this work order status field here. So what we're going to do is we're going to change the logic around so that some of our logic exists in the work order items table, or some of the data that we need to reference exists in the work order items table as opposed to the work orders table. And what we're going to do is move the status of the work order down into the work order items as well. So when we change the work order status, we're going to change it in work order items as well. And what that will allow us to do is change our calculation dramatically so that we can get a much faster report. So let's look at the difference here. So now we're on the much faster report. You can see I can scroll. We're not getting any spinning beach balls. It's just instantaneous. It's just working. And if we go to our work order and we change that, we're going to use the second option here to change it down to, say, closed, notice that all of the closed item, all of the work order items change to closed as well. You can see that up there. And now our report should still be accurate, the faster one. It should still say 7 up there, and it does, which is good, exactly what it's supposed to say. But because we've stored part of the logic in our system, we've stored some of that data in work order items, we've cached it there, we've denormalized it there, the calculations that we use to come up with these values are very different. So let's take a look at what those look like. So total closed faster. So that's what we're going to look at here. And in this case, we're doing a sum, but we're summing the quantity field from the work order items. And in this case, we're looking at a different relationship. We're looking at items that's through a relationship called items closed work order items. So if we look at that, what that is here, that's going to be this guy here. So we can look at our relationship. Our relationship is different. Now we're looking at, we have a constant field here that equals just the word closed. And we're setting that, we're saying, give me all of the related records that are in work order items that are closed, that the field work order status is closed, and the work order ID matches. So what this effectively does is it filters it down to only be the work order items. The relationship is now filtering to only show the open work order items, or in the case of the closed one, only the closed work order items. And then, so 2 things are happening. We're changing the relationship, and then we're looking at an indexed field on the other side of that relationship. So looking back at this again here, what's our items report? So the total closed. So this still may be looking at thousands or hundreds or even thousands of work order items. But since we're only looking at, I want the faster one there, but since we're only looking at a stored indexed field on the other side, it doesn't have to be indexed, but it could be. But it's a stored field. The quantity field is stored on that side of the relationship. This calculation is way faster than the other one. And then the open one is going to be even faster still, because it's not only looking at just this stored in quantity field on the other side in work order items, but it's also only having to look at the few work orders that are actually open. So in any given system, not that many work orders are open at any given time. So the number of related records that this calculation has to process is much, much lower. So these calculations are orders of magnitude faster, quite frankly. And that's the difference between this layout being like this, where it's scrolling super fast, and where it's not. Now, there are other things that you can do to speed up these calculations, or to make your reports faster. A lot of that depends on specifics in your own application, but this gives you a general idea of what the difference can be if you move some of your logic from unstored calculations into stored stored data, and then change around your logic to reference that stored data instead. Okay, so we've seen how much better this can be, how much faster. Let's take a look at some of the caveats that are involved here. So we have, let me go to the work order screen. We have successfully moved our logic out into some of our logic into the work orders items table to cache it there so that we can make our report faster. But the problem is that we now have a critical dependency, and something that can break if we're not careful. We have to ensure that the value in the work order status field here always matches the work order status field in the work order items table. And if anything happens that should get in the way of that, then we've broken our inventory report. So this data has to stay in sync. So in the logic that I showed before in this script that's being run by the B option here, what we're doing is using a replace to update that data. And the problem is that although that works, it's not very robust, and there are lots of things that can easily get in the way of making this thing just not work. So what are some of those things? Well, I'm not going to get into all the details now. I've got a great article on the website, which I'll have a link to on this post, that talks about some of the issues that come up when you're building multi-user FileMaker apps, especially networked apps. But there are a lot. A way to summarize it is to say this: there is no guarantee that a script that you write will be able to edit the records that you want it to edit when it needs to do so. And really, to state it even more boldly, there's no guarantee that your FileMaker script will even complete. There are lots of things that can stop that from happening. And again, you can find that information on the website. But that is true, and I'll show you one of them right here, and then I'll show you one of the ways in which we can fix that. So this script here is just doing a simple replace to keep the two values in sync. And let's take a look at that. So we'll open that script up. Here it is, and we'll just step through it real quickly. We grab the new status, the status we're changing from the script parameter, and then in this step we set the work order status field to that new status. And then we go to related records, showing only the related work order items, and then we use a replace to update all of the related records with that new status. And that does work, but it can also fail. And it can fail for a number of reasons, as I said. But so here's one. And this is a common one, and I'm going to simulate it by doing new window. And we'll simulate it by, so what I'm doing is I'm going to simulate another user working on a system. They're going into the work order, they're changing some item, let's say they change it to 6, and they're sitting there, they haven't committed the record yet, and I'm over here and I would like to close this work order item. So, I'm sorry, this work order. So I click B, and I try to close, and whoops, I get an error. It shows me an error, so my script is smart enough to know that. But if we look at the work order items here, we have a major problem. The first work order item and the work order itself are still marked closed. So we have a pretty serious problem. Our inventory report is now wrong. And that is because this record was not available to be edited. So it couldn't edit it. So it just left it. And so it left some of these open and some of these closed. And there's no way that we can actually know which ones it did it to, because replace isn't smart enough to tell you it was this record that didn't work. It just basically stops and it'll edit what records it can, and it won't edit the other records that it can't. So in a multi-user system, you will have record locking, and your scripts need to be able to handle record locking. So let's get out of that record, and let's just mark that back to being open. So we're back at the same state. Now in the third option here, option C, I'm using a FileMaker transaction to ensure that when I change this data changes. And if anything stops either of those two from happening, none of them change. And so that's the best way to ensure that your data stays in sync, is that you use a database transaction, or in the case of FileMaker, a FileMaker transaction, to make sure that your data stays in sync. So let's see what happens here. So if I change it just to prove that it works without any issues, we've got closed and we've got closed, so everything worked there. And we can change it back to open, and it changes everything to open. So that's all working. But now let's try to interfere with that. So let's go back here. We'll change this back to 8. This record is now locked and open. This record here, and the parent record is as well. And if I try to change that to closed, we're going to get an error. It says record is in use by another user. But the good news is that nothing happened. Our data is in the same state that we started with, all of the data. So we don't have to worry about half of the changes that we wanted to get committed being committed. The script failed to commit anything at all. So our inventory report is still valid, and our data is still valid, and everything is as it should be. So that is really the best way to ensure that when you denormalize your data, that it all stays in sync. And that way is to use a FileMaker transaction. And we're going to cover that a little more detail in another video coming up. All right, so in the demo we saw how to get rid of unstored calculations and to move some of that logic and some of that data into stored fields to dramatically improve the performance of your layouts. Now, one thing we pointed out, although did not go into depth in, and we will in another video, is that you really need to use FileMaker transactions to ensure the database integrity. to ensure your database integrity. Now that you're storing data in two places in your database, the same data really in two places in your database, you need to make sure that data stays in sync. And to do that, you really need to use FileMaker transactions. And we'll have another video on that. We'll get into depth in that. And there's lots of information on geisinteractive.com on how to use FileMaker transactions. So that's it. Thanks very much.